this is about black holes again. As you can see, I'm very interested in gravity. This is one of my favouriteest subjects. And exploring singularity, or infinity, or mass build-up. That's what I'm doing today. So you have three real possibilities, don't you? You have singularity, and that contains two possibilities. One of the possibilities would be zero, and obviously zero is infinity, because there's nothing there, like, you see what I'm saying, yeah? And that would equal that all the matter is dead and gone, and it's just continually sucking everything into nothingness. So it isn't a singularity, it's nothingness, it's infinitely zero. And of course, at this point, for the black hole to continue working, it would have to be continually fed with enough fuel, otherwise it would die, wouldn't it? In which case you would have a little bit of area in space. So everything's getting dragged into a bit of area in the middle of the universe. Well, yeah, possibility there. So there'd be like a funnel into it, and then there'd be nothing at the bottom, and all the matter would be getting destroyed and going to nothingness, and just being destroyed back into nothingness. The second idea is that there's one in there. There's a singularity, and all the matter's been drawn down a funnel down to a singularity, and in that case you'd have minus lots. It wouldn't be infinity, it would be minus lots, and there'd be lots that are dead and gone. So all the matter would be draining in there, and it'd all die apart from one little thing right at the centre called the singularity, and everything else is just pouring into this one thing that's left, and it's just being destroyed as it gets in there, mashed up into nothingness, and but it's been sucked in at such a rate it drags everything else in with it. So that's the two options you've got with singularity. And of course, at this point, for the black hole to continue working, it would have to be continually fed with enough fuel, otherwise it would die, wouldn't it? Now in my world, there's a mass there, and it's a certain mass. It can increase and it can decrease. So I call this mass constriction, or mass build-up. So they're your three options. Now, quite clearly recently, with the Keck telescope seeing a black hole feeding, and Hubble Space Telescope seeing black holes feeding, we've got pictures of black holes feeding, and you can see ejectors coming off the black holes, off them. And the biggest ejectors that we've seen, because we've seen quite a few black holes feeding now, one of these ejectors is as wide as the galaxy that it's in. Wow! So then we go into consumption rate, because obviously now we've seen that there's an ejector coming out of the black hole. So you've got the first option, which is the original option which Einstein came up with: nothing escapes, no ejector. That's completely obviously wrong. So Einstein's calculations are quite obviously wrong, clearly. No arguments. So then we've got first case scenario, ejector equals reflected output. So the stuff's going in, it's getting reflected out. That's one way. Then we've got the second type of ejector to consider. Ejector equals compression ejection. So it's being compressed, and bits of bobs are coming out of the matter, and then they're finding ways to be ejected out. And of course, they come out the North Pole and the South Pole. So that's compression ejector or reflected ejector. Now my calculations are compression ejection, and that's it. I've said it in other videos, but obviously you've got to take into account reflected output, because there's a possibility that it's reflected output as well, and you're going to have to do those calculations. So I've come up with four possibilities for reflected output. One would be funnel constriction limits. So obviously when you're seeing the matter come in the funnel, only so much can be compressed down to your singularity, and it creates like a reflector or a mirror, and then it reflects it off that. The second one would be called incompatibility matter. So all the matter going in, some of it's not compatible, it can't be compressed to whatever, the singularity or whatever, so then that gets ejected out. The third one would be gravity mass expansion rate. So as the funnel fills up with matter because it's feeding, the gravity mass expansion rate is so quick that it tells it to get aware of it. I know it's similar to a funnel reflector. Or constriction limit. And then you've got increasing heat oscillation matter. So as the matter builds up inside the funnel, as it hasn't got to singularity yet, the increase in heat creates oscillations, and then the oscillations reflect the heat out. It's similar to reflection as well. It's all to do with reflection then, isn't it, if you're doing a funnel? But then of course you've got to have two sides, and it gets quite complicated if you continue using singularity, because it's a dipole, the singularity is. Although, you know, it might be reflection in the telescope. It's up to you, but you're going to have to come up with your theories. I'm going along with compression ejection, because I think that's what happens. I know that's what happens. And then of course, if you're going to go with your reflected output, and you're going to continue with your singularity or your zero infinity, if it's going down to a single point and everything's being crushed into that single point, the only way to keep the black hole going would be for it to continually eat enough matter. Now, if it's eating open space, so let's say it's at its solar system, right, and now it's at its solar system, so it's in interstellar space now. You know what I mean? No, it's only got interstellar matter to feed on until it finds another solar system. So it has to float around interstellar space now until it finds another solar system. And at that point then, the black hole funnel, where it's getting crushed into singularity, is forever getting smaller and smaller and smaller and smaller and smaller and smaller and smaller. At some point it's going to lose cohesion and break back into a light, into a star again, surely. So if you had a singularity, and the calculations for singularity obviously don't go to infinity, otherwise the universe would be collapsing, or where's the new universe matter coming from? So your calculations for singularity mean that the universe wouldn't be expanding. So quite clearly, again, Einstein's calculations are a little bit off the mark. Fucking miles off the mark. Because the universe is expanding still. And at what point is it going to stop expanding? If Einstein's calculations are so fantastic, you'd be able to go, right, and the universe is going to stop expanding at such and such and such a year, 2 billion years in the future, 4 billion years in the future, or whenever, yeah? And at that point then the universe is going to collapse upon itself. Yeah, right? But the fact is, the universe is expanding and it's getting bigger. So quite clearly, it's not being compressed into a singularity. There's no such thing as a singularity. You're talking mind-boggling, stupid crap, right? And it just leads you down the road of madness. What it is it's an accumulation of mass. And similar to what Einstein has said, where light can't escape because the gravity is so much, well, there you go. It's a star that's that powerful, and it's too cold because it's lost its ability to be a star anymore, but it's that powerful, like a white dwarf that's continually shrinking, like, yeah, it's like a white dwarf, but there's that much matter there that it can't radiate the heat off anymore. Sorry, it is radiating, but it's continually slamming itself back onto it. It can't radiate it far enough for it to reach to us. That's the simple fact of the matter, is it's got that much gravity that the little amount of light coming off of it now, when it was a blue giant, you could see it. It was the brightest star in the universe. But now it's not. Now it's dead. It's lost its fusion. It isn't doing fusion no more. And it's massive. It's like the biggest planet you've ever seen, but it's now not in a solar system, not got a star, and there's no hydrogen in it. It's not hydrogen anymore, it's all heavier metals and heavier elements. There's no hydrogen left for it to be a star anymore. It doesn't matter if it's gaseous. It could be gaseous lead, but it's that heavy. Even if it's doing lead fusion and getting heavier and heavier and heavier and making element 753, because there's that much gravity, light waves aren't being emitted from it anymore. But guess what? Gamma rays are. So while the gamma rays are that small that gravity can't grab them, in other words, the oscillation of them's too tiny for gravity to grab hold of. And X-rays, gamma ray burst, X-ray burst, quasar. So you've got to pull this Einstein crap out of your head, calculate new calculations, and come up with new things. You can't be stuck 100 years ago. You can't keep on making the wooden table when we've got new materials. You can't keep on making the candle when we've got the incandescent light bulb. You can't keep on making the incandescent light bulb when we've got the fluorescent light bulb. You can't keep on making the fluorescent light bulb when we've got the light emitting diode light bulb, and so on and so forth. It's called evolution.